Hello everyone and welcome back to another Pika Education video. Today we're doing algebraic proof for the 2022 set. You might ask why we have skipped 2020 to 2021. Well, not just those two, but 2023 and 2024 don't have any dedicated questions about algebraic proof, which is why we're doing only 2022. Without further ado, let's begin. Make sure to thunderbolt the like button and electroball the subscribe button. So let's go. For the 2022 set, there are two dedicated questions about algebraic proof, and both of them are in November. So let's start with question 16a in the non-calc paper. For this part, we have to prove that this equation is true. So firstly, most of you might be able to see that the left-hand side is in the format of a squared minus b squared, which means we are using the difference of two squares. It's going to be a plus b multiplied by a minus b. So the left-hand side is equal to 2n plus 1 plus 2n minus 1. That's the first bracket. The second bracket is 2n plus 1 minus 2n minus 1, which is equal to 2m plus 2n. The ones cancel out for the left bracket, and the right bracket is 2m minus 2n plus 2, because double negative on there, which means if we factorize 2 from both of the equations, it will be 2 multiplied by m plus n and 2 multiplied by m minus n plus 1, which shows it will be 4 at the leading coefficient if we have our 2 multiplied m plus n, m minus n plus 1, which is the answer for the left hand side, which proves the left hand side is equal to right hand side, as the left hand side is now equal to the right hand side. And that is the first question. For part B, Sophia says that the result in part A shows that the difference of the squares of any two odd numbers must be a multiple of 4. So, is Sophia correct? We have to give a reason. Well, this is true. Now I'll give you the reason. Firstly, we know 2m and 2n are even numbers because they're a multiple of 2. And also, m and n have to be integers. So once we put plus 1 and minus 1, they are both still integers, even though they are both odd now. So according to Sophia, she said that any two odd numbers for difference of squares must be multiple of 4. Since 2n plus 1 and 2n minus 1 are odd numbers, for any positive integer value of m and n, and we have shown that the right hand side and the left hand side can both be expressed as a multiple of 4. Therefore, Sophia is correct. This is part B. Let's go on to the last question. For the last question, we'll have to use algebra to prove that 1.062 and the 2 is recurring can be written as 1 and 14 over 225. So, let's say since x equals 1.062 and the 2 is recurring, it's also equal to 1.06222 ... We're going to multiply x by 10 to get 10.622. We're going to multiply x again by 10, which is 100x, to get 106.222. And let's go and subtract 100x minus 10x for the left hand side. And the right hand side will be 106.222 minus 10.622. You can get rid of the zeros because, well, since both of these are recurring, so it just becomes 0. 6 here. 5 and then 9 to get 95.6. So 90x equals 95.6. Now next we're gonna move 95.6 to numerator over 90 and multiply it by 10 to get 100. So we're going to have 956 for the numerator and 900 for the denominator. Since x equals 956 over 900, we can divide this to make into 239. This becomes 225, which means x is equal to 1 and 14 over 225. That means we have proved the question. Thank you to everyone who watched it to the end. I really hope you enjoyed this video about algebraic proofs for the 2022 set. I have recommended videos right here. Make sure to like and subscribe, and I'll see you in the next one.